We're on the last section that we're going to cover any new material. After this, it'll be just runtime review for your IB exam at the, in May. So we're going to be talking about analyzing univariate data. Statistics will probably take us into the middle of next week. I'm thinking about just quizzing on statistics, not testing, and then just going from there. Okay? So, univariate analysis involves a single variable such as height in a class. Okay, so univariate means one. So we're only talking about a single variable. Okay, not comparing two things together. There are two types of data that we can be dealing with here. We can talk about qualitative data, which are like your categories, and then there's quantitative data, which is stuff that can be counted or measured. Okay. Now, with quantitative type of data, there are two different types. There is discrete, which are like the number of CDs that you own, and then there's also continuous data, which is stuff like times to finish a race. Okay, so discrete are things that can be counted. Continuous are things that can be measured. Okay, so times, weights, things like that. Those are all continuous. However, number of CDs, the amount of fish in a pond, shoe sizes, all those things are examples of discrete data. Okay? Yes?
We never talked about
when we're talking about probability, the difference between continuous and discrete, so it's the same type of stuff. When you're doing a statistical investigation, the whole group which you collect your data from is known as a population. Okay? So if the questionnaire refers to, the population of 200 people, then you're talking about the whole group in which you collect your data. Okay? Your vocab words before we get into the goods. All right. Now, a sample is a small group chosen from the population. Some of these words, hopefully, they sound familiar from your original dealings with data and stuff like this. But a sample is a small group chosen from a population, and a random sample is one where each element has the same chance of being included. Okay, so it's not like you're being biased, which is one that is not random. So if you're trying to take data, I can stand at the gym door, and then I can, pick every third person and ask them what's their favorite candy. That right there is random. However, if I go into this class or Pretorius' class or Fisher's class to see, what's your favorite type of candy, that is being biased. Someone considering one group, which would be the IB group. Okay. When there is a large amount of data, sometimes it's easier to interpret the data if it's organized into a frequency table or displayed as a graph. Okay. And now starts our examples. Okay? So, here's an example when you have a set of data. This right here is students count how many cars passed his house in a 1-minute interval for 30 minutes. The results were as follows, okay? Now, granted, yes, 30 pieces of data, it might not be a lot. However, you could have a grip of data, okay? We're going to display this data into a frequency table, and we're going to draw a bar chart from this data. Everybody knows what a bar graph looks like?
Yeah.
Okay.
Easy.
Now,
He's sitting out there. What do people constitute in
Okay. So, the one thing you want to be careful of when you're doing statistics is that if you ever have to draw a graph yourself, they do give you points for labeling your axis, making sure you have the right scale, so do not lose any points there by not labeling graphs, okay? And please, if they ask you to draw a bar graph, don't draw a line graph, okay? So please do what they ask you to. So frequency table. Let's do this out. Okay, now frequency table is basically a table that organizes your data nice and neatly. Okay? Organizes it nice and neatly. And instead of having all these different pieces, like we have 23 here, and then we have 23 again here, and so on and so forth, we just basically, see how many times these numbers show up. Okay? So we're going to do a 2-column table. This first column is going to represent the cars, the number of cars.
The number of times.
And that's called your frequency. So what's the smallest number of cars you saw in one of the minutes?
20.
So 20 will be one of our things, and how many times did 20 show up?
The 2 times.
2 times. Was there 21 cars anywhere? How many?
5 times.
Only got 4.
In the middle between 20 and 20.
Oh, thank you. Alright, and this is how you create a frequency table. You basically organize your data nice and easy, okay? So can you guys finish off this table?
I like to know like elementary style where you keep after number 5.
Alright, so how many 22 cars were there? 7. And 23 cars? 6. And 24 cars?
1,
And 25 cars?
2,
26 cars?
3,
27 cars?
3,
28 cars?
1,
29 cars?
0.
There were no 28 was the highest?
Maybe
So then there you go. There is your frequency table. Now one thing you need to one thing you always check whenever you create a frequency table is count up your frequencies. Okay? The total number of frequencies should be the total number of pieces of data that you have. Okay? So if he counted for 30 minutes, he should have 30 pieces of data if he did it every 1 minute intervals. So all these numbers should add to be 30. And then you order. Okay? Now, make a bar graph. And I know a lot of this seems really elementary and really basic, but it's better that I go over it now instead of making the assumption that, oh yeah, you guys have it. Let's keep going.
Not tell Brian, but it doesn't like, well,
What's a bar graph? I didn't know what it was before.
Yes. Okay, so simple enough. Make sure it's your label. And label your x-axis. These are number of cars. How am I going to label the other axis? Frequency.
they want to give you a smile. Because he's like, great, I don't know who people who can help kill me. That's why I smile. The episode of Walking Dead. Oh.
Are you doing your bar graph and talking about all of
Yes, man, doing it at the same time. I know, and I wish I was as talented you can drink from a half straw. Man, there we go. It'll be just straw in a little bit. I'm good. Yeah. 1, 2, 3, 4.
So roughly. Did Harrison look younger?
I think it looks good.
Now, when there's a lot of data spread out over a wide range, sometimes it's more useful to group the data. If you ever have to do a grouped frequency table, you want to make sure that you have between 5 to 15 groups. Sometimes these groups are called classes of equal width. Okay, so you don't want to have one group that goes from like 1 to 5, and then the other group that goes from like 6 to 20. They have to be of equal width. The classes cover the range of values that fit your data. And lastly, they cannot overlap. So when you're doing your intervals, the intervals cannot overlap. For this data, you can draw what's known as a histogram. Now, a histogram is very different. Sorry, it's a tad bit different from a bar graph. It does look like a bar graph. However, there's no space, there are no gaps in between the bars. So basically, the bars are going to touch and connect each other. So, like, here's one, the next one will be here, so on and so forth. That is a histogram.
Why does that matter?
Because if they ask you to draw a histogram,
You draw it.
you want to make sure that there's no space in between the bars, so that you're going to lose your points.
If you drew that when they asked you to draw a bar graph, would you get points off?
Ooh, they're more likely going to ask you to draw a histogram versus the bar graph.
Kids have already failed.
All right, so here we go. We have 200 members of a tennis club are here. This is 200 pieces of data. Okay, now doing a regular frequency table is going to be still very extensive because you need to have one for 20, 22, 23, 24, 25, so on and so forth. But for this, you can draw a grouped frequency table, and we're also going to draw a histogram for this data as well. So we need another table, but this time it's going to be grouped.
Still like tens.
No,
10.
10 is 20. You at least 5 groups, you said 10 of them.
A minimum of 5, but no more than 15. Okay, so how you want to go?
Tens.
By 10? Okay, so this represents
Ages.
your members. Oh, ages. What's the members? then we'll have our frequency. Okay, so if we're going by tens, then this age group, the lowest is 20, so then we'll go from 20 to, it'll be 30. Now, for this, how about we won't equal it to 30 for this group, but then the next group it will equal 30. How about that? Does that work?
I mean, how else would you do it?
Well,
I mean, otherwise you
like you
have
go to
a gap.
30, then you go 31 to 41, and then you go 42 to
It makes more sense to just do it. Does the number start with a 2, 3,
I
4?
just did like 20, 29, 30,
30,
39, 40, 49.
Okay. If you do it that way, if you go 20 to 29, 30 to 39, there's something that you have to be cautious of when you do your histogram. Okay? But if we can do it. You guys want to do it this way?
Yeah.
Okay. All right. We can do it this way. True. If there was a 29 and a half, then you couldn't do it.
Well, then we wouldn't do it this way. There's no 29 and a half.
We can do it this way. Would it be?
It'd be less than equal 29.
Oh, now they're good.
This button stop? Smack it.
Too much. I'm going all the way to 69.
Yep.
Seriously? So there's your group frequency table. Now you basically do the exact same thing that we did before. You count how many numbers actually fall in these groups. Okay? So between 20 and 29, how many numbers is that?
16.
Can I get a confirmation?
Yes. I got you.
Alright, so 16. So from 20, 29, there's 16. What about 30 and 39?
I'm getting right now.
I'll give you guys a minute. Complete the table and then we'll compare answers. Alright, so between 30 and 39, what you get?
38.
38?
Are we really arguing you can count faster?
Good stuff. 40 to 49.
68.
68?
68.
Awesome. 50 to 59.
55.
55 and the last one. 23, yes. And again, you can always double check by adding in your total frequency should be the total number of members that we have. Okay? So good stuff. So there you go. There's a group frequency table. Now, to make your histogram, if you do it this way, or if they give you a group frequency table and you have to draw the histogram yourself, when you graph this, if you try to graph it the way it is now, you'll have basically a bar that will go from 20 to 29. You have another bar that goes 30 to 39. There's that space, there's that gap between 29 and 30, correct? The histograms can't have a gap. So in these types of cases, when you have a group frequency table and the numbers are not the same, like this upper bound number, this lower bound number are not the same, you basically have to do the average, the midpoint between those two groups. And then that's where the bar is. Okay? So,
Should have done it her way first time.
Exactly.
all right. So here we go. So let's go ahead. Let's set up our graph. We're gonna label 40. 50.
You can add to it.
These are our ages. Y is still our frequency. We're gonna go by 10s, 20s.
Five. No.
5 all the way to 70.
I'm gonna go by 10s.
I would have done by 12.
What?
Why? Okay. So basically, whenever you have a frequency table like this, you basically need to define what's known as your upper bounds, okay? Your upper bounds are basically the number that,
Question.
yes,
Aren't you missing a thing right there? Like, you know, on the bottom of the x-axis, like the little weird thing?
you're talking about a little break.
Yeah, because you're jumping from 0 to 20, then going up by 10.
So, to draw the rest of your bar graph, because you need to draw one that goes from 20 to 29 and represent this frequency of 16. But you're not going to stop at 29, you're not going to start your next bar at 30 because it needs to be histogram, the bars need to be touching. So you find what's known as your upper bounds, and that's where you draw like the end of the first group, the beginning of the second group. Okay? And the upper bound is the number that's halfway between this number and this number. What's halfway between 20 and 30? 29 and a half. So you're going to draw this first bar. It's going to start at 20, and then it's going to end at 29.5. Okay? So we got to go up to 16.
Why don't
This is what's going to allow your bars to touch when you draw your histogram.
wait, if we did it your way, wouldn't we have the same issue?
Because it would be everything leading up to, because it was less than 30,
Well,
and then other was equal to 30. So we'll go all the way up until 30, but the bar for the 30 would actually be touching.
Well, I could just draw it the other way anyway, right? Because the numbers are the same.
Yeah, you can draw, but the thing is that they're gonna, like what I've seen in markings is like, you know, do they have bars hitting at, if this was given to you and you had it graphic, they're gonna be looking to see that the bar is gonna stop at 29.5 and 39.5 and 49.5. Like that's gonna be a point on your marks. Now if you're willing to, get that point up, that's fine, but I'm just letting you know. So the next one's gonna be 39.5. So you'll start at the last lower bound, which is 29.5, and you're going to go to 39.5. And this pattern continues. Halfway between 49 and 50, that's 49.5. So you start at the last one and keep going. And this just continues. 59. Now for this last one, if I were to continue this pattern, what would my next number have been in my next class? It would have been 70, so you're going to take the halfway point between 69 and 70. Even though I know it's not there, but you need that last bound, so then it'll be 69.5 in your answer.
I didn't draw mine. I love that jump from 10 to 20 and then the 20, 30 jump.
45 under something. Like 100
Here we go.
and something.
Measures of central. I know this is all right. All right. Measures of central tendency tells us where the middle of the set of data lies. Okay, these are things that you guys should know: mean, median, and mode. Yes. You will need your calculator. And not for some of this basic stuff, but later on you'll need your calculator. Okay. Mode means what?
There's my number right there. I'm telling you, that's what I was doing.
Mode means most. The one that shows the most often. So, an example, find the mode of this data. Our mode is 15. The one that shows up the most. It shows up 3 times. Okay? So, yes. Sometimes they'll ask you to find mode. Okay? And you take those, you smile, you say thank you. And you keep it moving. Before anyone asks, could you have 2 modes? No. In the IB classes, in the IB exams, there's only going to be 1 mode. So if you have to create your table or you have to analyze your data, if you come up with 2 modes, you need to double check because you probably overcounted or something. When it's presented in a frequency table, the mode is the group that has the largest frequency or the biggest frequency. So it says find the mode or modal class. These things mean the exact same thing, okay? Modal class is the class that has the most, all right? So for here, what is the mode?
More than one.
It's 1. The 7 tells us that this is the largest number, but our x values are the goal. So 1 goal is the mode. And over here, what's our modal class?
15 to 20.
15 to 20, and you write it out exactly the way that you see it. Okay? So mode we're straight, right? Hopefully, I have no issues. Okay? Mean. How do you find the mean? Or what is mean? Mean?
Average.
The average. How do you find it out?
Add them all up and divide by the number.
Yes.
Yeah.
Now, mean is
Yes,
represented by this symbol, lowercase mu. You've seen it before when we're doing normal distribution curves. Okay? Okay, stands for mu. I'm just going to go ahead and give you this formula right here. What does that symbol mean?
All real numbers?
Try again.
The sum.
The sum of all your x's divided by however many you have. Okay, that's the general formula there. And sorry, I'm using capital N because that is what is in the bottom red part. Where sigma x is the sum of all the data values and n is the number of data that you have in the population. So I have no doubt that you guys will have no issue doing A and B.
Sure.
It's because you clicked alpha.
Alpha.
All right. So you add all these up. What was the sum? Anybody find the sum?
4, 5, 5,
595.
595.
You shut up there with your fancy math speed part.
That's how many dollars I got.
You divide it by 7. What do you get?
85.
85.
So that's 7 ways.
This one here. What was the sum?
25.
You divide it by
6.
what do you get?
4.17.
Rounded.
Would we put it as a decimal or could we keep it as 25?
You keep that first.
That's disgusting.
Questions?
They don't hand out dollar bills and fractions, do
Can
they?
you make this stupid?
These are your basic ones.
Yes.
If they give you the mean, or they ask you to find the mean when you have a frequency table, what you need to do is you need to take into account when a frequency tells you how many times the numbers show up. So you have 11 zeros, 10 ones, 19 twos,
We're doing this non-calculated.
and 3 tens. And 10 threes. Okay? So to actually find the numerator, to do the mean, what you actually do is you multiply the x values by your frequencies. Okay? So 0 times 11 is 0, but 1 times 10 is 1 times 10, 2 times 19 is
38.
38, and then 3 times 10 is
30.
30. Add all these up together.
Oh, I don't know. 70.
I'm gonna do it by hand.
That's your numerator. Now you have to divide it by n. N represents the number of pieces of data that you have. In a frequency table, that is your total frequency. So what is 11 plus 10 plus 19 plus 10?
50.
So that's what you're going to divide by. So it's 78 divided by 50, and that is your mean.
1.56. I did that without a calculator.
Now with these, with the group frequency table, a lot of times they'll ask you to estimate your mean. Because you can't exactly figure out what is the exact mean because you do not know how, out of the 4 pieces of data that are in the first group, you do not know if they were all 4 10s, or if it was 2 11s, and 2 12s, or if it was even some decimals there. So what you do is you're going to estimate the mean in these cases, and to do that, you actually need to find the midpoint of each group. What's the midpoint of each group?
11.
13. 15. 7.
Good job.
So you take the midpoints, and those are the x values that you use to estimate your mean. So then you take all the midpoints, and you multiply them by your frequencies, and then add them up, and that's going to be your numerator. So what's 11 times 4?
44.
8 times 13?
104.
15 times 5?
75.
17 times 3?
51.
Add all those up.
I'm doing more. Oh, come on. You use calculator. That ain't fair.
And then you divide it by your frequency still. Because you have this much data. What's that sum?
20. 1.74, right?
What? 13.7, partner. Check your mathematics.
20 goes 1.7.
20 times
But these are the numerator and denominator, right?
Yes.
Mental math.
Questions on the mean?
Yeah. I had mental math. Mental math.
Right? These are more likely the types of mean questions that you'll get. Same thing with the mode questions, they'll ask you with a group or a regular frequency table. Sometimes they'll ask you to do something like this. It'll tell you that Atlanta's mathematics test grades are 86, 93, 89, and 85. What score must she get on the fifth test in order to get a mean of 90 for the term? This is a good old SAT type problem that I'm pretty sure you guys have seen in your lifetime.
I can do this.
Oh, yeah.
All right, I'm gonna let you guys go ahead and do it. So, to figure this out, yes, you do take the sum of all of these numbers, 86, 93, 89, and 85, okay? Then you have that last test. That's a total of 5 tests that will give you a mean of 90. Now, I know some of you guys are probably not setting it up this way, but this is the setup to get the method point, just in case you get the wrong number.
Okay, the other value, this is how you did it.
What's 9 times 5? 450. What is the sum of these numbers?
About 353.
Yes.
353.
So then you just subtract, and the last test would need to be a what?
97.
A
Better than
97.
she's ever done.
Well,
She's
actually,
gonna fail.
all you need is a 95 to get 100 this time.
That's true. And this is very much so. I don't know. I don't say much when y'all get these actions. All right.
So in reality, she has a 95, 95.
So what does median mean?
Middle.
The middle, but you gotta make sure that what?
And they're in order.
They gotta be in order
This one's 23, I guarantee it.
from least to greatest. You gotta make sure. Okay? So find the median of this.
Okay.
Alright, what's the median?
23.
It was 23, put them in order, or if you decide not to put them in order, you just play a point or whatever, that's fine as long as you get the right median. Okay? Now, the last little bit that we'll talk about today are measures of dispersion. We talked about this already before when we were referencing our normal distribution curves. They describe the spread of the data around the central value, aka the mean. Range is the difference between the largest value and the smallest value. So they ask you to find the range, just normal range. You just do max minus min. Quartiles separate the original set of data into 4 equal parts, hence why it's called quartiles. And then we can actually represent some data instead of a histogram. We can represent it in a box and whisker plot that summarizes the 5 statistical data graphically. Okay, so you're adding this in. This is what a box and whisker plot looks like. Hopefully you remember this from your days
Yes.
a long time ago.
They
You have your box. It's literally like a box. You have your whiskers, which are the pieces that stretch out from the box, and then you have your min on the left and your max on the right. Now, the first part of your box is your lower quartile, aka Q1. The line in the middle, and will always be directly in the middle. It might be closer to the lower quartile and closer to the upper quartile, but that is your median, known as sometimes as Q2. And then you have your upper quartile, which is known as Q3. Okay? There's such a thing called your interquartile range, very different from your normal range. Normal range,
they try to be split like
normal range, you just subtract the max from the min, but interquartile range, you subtract Q3 from Q1. That is basically the middle half. That is where 50% of your data lies. Okay? So basically, your box and whisker plot breaks your data down into quarters. You have 25% here, 25% here, 25% here. That's where the middle half is, the middle 50%. And then you have the last 25% on the other whisker. Now, an outlier is any value that is at least 1.5 times your IQR above Q3 or below Q1. So if you're given a number and it asks you to figure out if it's an outlier or not, what you do is you take 1.5, you multiply by whatever the IQR is, and then either add it to Q3 or subtract it from Q1. If that number falls within those two, then it's not an outlier. But if it's outside of it, it is. Alright, now there is a relationship, because remember, box and whisker is one way to represent your data, just like the how a box and whisker plot is basically spread out. Okay, so do realize that those two pieces, they do relate to each other. All right. So we're gonna look at this one. We're gonna find is this one on your notes?
Yes.
Okay.
Shoot.
Yeah. All right. So it says to find the range, the median, the lower quartile, the upper quartile, and the inner quartile range of this set of scores. Okay. So you have these scores here, and you need to figure out all this information. Well, the range is pretty simple. All you do is you take
100 minus 18.
the max and minus the min, and you get a range of.
82.
So that means your data basically is spread out amongst 82 pieces of data. Now the median. Of course, we can do old school median to figure out the number in the middle.
Or you just look at it and say, hey.
So find the median. Let's go.
I would say, hey.
There's another way that you can do it, but I'm gonna save that for our next class.
52.
Confirmation.
68.
Where'd you get 52?
I guess.
These are in order.
Oh, they're already in order.
Yeah, it's already on.
You just look.
Oh, I need new glasses.
Now the lower quartile, okay? That is AKA Q1. That represents like is the end of the lowest 25%. Okay? Now the way I can do is basically take your data and divide it by 4. That basically breaks you down into quarters, okay? So you take
15.
not
15.
15.
That's
Where are you getting 15 from?
the number of down points.
Okay.
Or would you use 82 in this case?
No, you can use 15.
Okay.
It actually is plus 1, sorry. So it's n plus 1 divided by 4. You add a 1 and then divide by 4. If you're like, where does formula come from? Well, it's going to make sense when we do cumulative frequency curves on Wednesday. But this is basically a general formula that you can use to find your Q1. Okay? So if you say there's 15 pieces of data, 15 plus 1 divided by 4 is 4. So 4 is not your Q1. 4 tells you that it is your 4th piece of data. Your 4th piece of data is your lower quartile, which would be what?
52.
52. Okay? So that formula, again, does not tell you what your lower quartile is. It tells you where in amongst the data to find it. Okay? All right, and we can do the same thing to find the upper quartile, which is Q3.
87. Would you go from the right to the left?
That formula,
It doesn't matter.
all right, it's basically, and since it's the same type of process, n plus 1, but you multiply by 3 and divide by 4, you're just trying to find the top 75%, which is what? What is
85. No. 87.
It's going to be 87 because when you plug 15 in here, 15 plus 1 is 16, times 3 is 48, divided by 4 is 12. It's your 12th piece of data, which is 87. So again, these formulas do not tell you what they are or where to find them. And lastly, your IQR, your interquartile range. You do Q3 minus Q1, and that's the actual values you got for Q1 and Q3. So that's 87 minus 52, which is 35. So that means that 50% of your data lies within 32 numbers.
35?
Now it says to show this as a box and whisker plot, okay? With every box and whisker plot, you need a horizontal x-axis, okay? You need to make sure that you label that x-axis. This right here represented what? What are we talking about in this problem?
Doesn't say.
It doesn't say?
I just said that.
All right, so in this case, we're just going to leave it as x, some x values, okay? And of course, we want to make our scale pretty even, pretty symmetrical. Our smallest value is 18. Our largest value is 100. So what? So by tens? It's always good to keep your scale consistent because if you're ever asked to compare your box and whisker plot to histogram to see how it's skewed, can help you with this. So we need our two ends. We need our minimum value, which is at 18. We need our maximum value, which is at 100. And the box is always bigger than the ends. Okay? So I need an edge at 52. I need an edge at 87. And now I'll make my box. I need my whiskers that connect my box. And the last thing I'm missing is my median, which is at 68. And there's your box and whisker plot. The median won't always be in the middle of that box, okay? If anything, that should tell you that like the closer the median is to either one of the quartiles, just let you know that 25% of your data is within a small range of numbers. Okay? Now if it's smack dab in the middle, that means it was basically equally proportioned between the middle 50%. Okay? Now it says we need to see if 18 is an outlier unless there are any questions. Am I going too fast? How are we doing? Okay. So I have to figure out if 18 is an outlier. Remember, you have to do 1.5 times your IQR. Okay, well, my IQR was 35, so what's 1.5 times 35?
See, it is 105 over 2, which is 52.5.
So what you do is you add 52.5 to Q3. What's 52.5 to plus 87?
139.25. 0.5.
Okay, and then you take this number and you subtract it from Q1. What's 52 minus this?
Worse and worse.
Negative 0.5.
Negative 0.5. So basically, your number
52 is 0.
has to lie in between these two numbers. Does 18 lie in between these two numbers?
Yeah.
Yes. If it lies in between these two numbers, then no, it's not an outlier. If it actually was outside of those two numbers, like if it was like -1 or if it was 150, then yes, it would be an outlier. That's how you determine if numbers are an outlier or not in your data.
Wait, what did you get? Negative 0.5?
You subtract it from Q1.
Oh.
So basically, you'll do Q3 plus this number, and then you do Q1 minus the number to figure out what basically is the range that would make something an outlier or not an outlier. Any questions?
This is
Oh, no, I didn't. Okay, so Brian, this one's mostly for you, okay? And your homework on the back side, number 5, you can't read the bar graphs, the bar plots for box plots for A, B, and C. So here they are, okay? This is where the median is. This is where the lower and upper quartile are. And then you also can't see number 4 that well. So again, this is number 5. This one's number 4.
Hi, Brian.
Okay, so this is how the box is broken down because you needed to answer all those questions. Okay, so this is number 4 here.